Happy 2022, everybody. I hope you guys have a good, rested, chilled winter break. All right. Wonderful. Awesome. So let's go ahead and get into this lesson. Parent functions. Now, before we continue, I do want to say this to you guys. And this is pretty much how we're going to operate. Stay ready so you don't have to get ready. What does that mean? Simply mean that you're on your grind from start to finish. And you're gonna hear me say that phrase a lot. Stay ready so you don't have to get ready. Alright, come on with it. Let's get to it. For this lesson, you would need understand K, make the graph move on the y-axis. Understand H, make the graph move on the x-axis. Understand A and B as the graph starts to shrink horizontally and vertically. Understand the domain. Understand the range. Understand the intercepts. Understand the symmetries. Increase and decrease, and the asymptote. What's an asymptote? You're gonna find out, y'all. All right, back to the business. So independent work. So we're going to get into decimals. And in decimals, what we're going to do, we're going to learn how to input the parent functions, identify and describe the characteristics of each function. The assignment is very independent, no good work at all. Failure to comply will result into point reduction. Again, this is the little app right here. So you may want to download that on your phone if you have not did so already. That's going to be the best thing to help you out throughout the year. All right, here's an example of which I created. So I have a polynomial function, which is right here. So when I'm talking about domain, I'm talking about from the x-axis. So when I start drawing, you notice that the graph keeps going. If I was to put this in decimals, which I will, you will see how it keeps going and never stops. So that's the reason why it's going from the smallest numbers all the way to the positive numbers. So negative infinity to positive infinity. That's the domain. The range talks about all the y-axis. And the same thing happens. As I keep going with the graph, it keeps going and going and going and going and going. So that's just that. So let's talk about intercepts. So intercepts are when the graph crosses the x and y axis. So let's look here. Let's find out what x value is. I told you it's negative 1.7, and that happens because right here. That's why. That's the x-intercept and the y-intercept. When it touches the y-axis, I get 4. Do I have any asymptotes? No, I don't. Because the graph keeps going, going, going. There's not a stopping point for this function. Let's just keep going. What about other things do we notice? What about maximum and minimum? So here's a maximum right here, and right here I got a maximum at negative 1.5 and a minimum at 0.4. And that's all we are essentially doing for today. Something very simplistic and easy. Now, in person, I will be teaching you how to snip these graphs off from Desmos, so you could put it into the homework, because your homework is going to be you graphing, you doing what I'm just doing in these examples. All right. All right. In Desmos, the first thing that you're going to put in, you're going to put in a function like this. Type it in exactly like this. I will be able to help you with the Desmos to put in these functions in the Desmos. All right. So remember, for the quadratic, and there's a quadratic function, I need for you to describe all the characteristics of that one. And then after that, I want you to do the square root function. And you're not doing them all together. Forget, one by one, I will be walking around to help you make sure that you're doing them one by one. And there will be a small tutorial video of doing this in Desmos. All right. And then you're going to do the same thing for the cube function. And then you're going to do it also for the cube root function. And then from there, you're going to do it for the logarithmic function. And then from there, you're going to do the exponential function. And then from there, you're going to do the absolute value function. And last, and most importantly, you're going to do it for the rational function. So there are eight graphs that you're going to be doing in Desmos, but don't forget, for each one, as how random, you're going to do it one by one to address all the characteristics possible, as I did in the previous example. All right. You're going to pause this video, and once you are done with all of that, then we will compare. All right. Welcome back. So let's talk about these characteristics. So what is the one thing that stands out to you for these functions? They're opposites of each other, believe it or not. So this is the inverse of this, and this is the inverse of this. Very imperative for you guys to keep that in mind, because you will be solving these types of equations, so you gotta learn how to take the inverses of that, because remember, that's what equations are all about, taking inverses of stuff. So the domain of a quadratic function, as we know, it never stops, so it's all real numbers, or negative infinity to positive infinity. And you denote this with R. The range is dealing with the y, not the x. The x is the domain. So when we're going for the range, from what we did, range was 0 to infinity. Now I want you to take a moment and figure out why did I use a bracket for 0, now parentheses. Intercepts. The only thing I do is write the word yes, because usually you're going to have more than one. Usually you're going to have 2 x-intercepts. And if you get lucky, you probably have 1 y-intercept too, so it depends. But in this case, you got 2 x-intercepts and 1 y-intercept. Asymptotes. With this graph, it makes a continuous move from the domain, but the range, it starts off at a point. So you have none asymptotes, because asymptotes is like a line that never touches. The mix, miscellaneous. Well, you have a minimum around the origin. So let's talk about its inverse, the square root function. Now, the domain of this, just like the range of the quadratic, is going to be with the bracket 0 to infinity. Again, ask yourself, why am I doing that with the bracket? Well, now I could tell you. It's because that's where you specifically start at. You start at 0 here, at a specific point. You start off at a specific. The parentheses you see with the infinity, it could be any number. It doesn't stop. Any number. It does not stop. Intercepts. You don't have any, so you can write down NA. And then what about asymptotes? That's not in this case. Anything else you could say about this function? Other than it's the inverse of it? Well, that's pretty much just it for that. But again, the brackets are when you get a specific number that keeps going. It starts at a specific number. It keeps going. Parentheses is more of a, it could be any number because it keeps going and never stops. Now, momentarily, the parentheses are going to have a different meaning, and we're going to talk about that momentarily. All right, guys. Let's go ahead and get on with this one. So the cube and the cube root functions, although they are opposite of each other, but the characteristics are exactly the same. The domain is all real numbers or negative infinity to positive infinity. So again, you can use R, which represent all real numbers. Range is the same. Intercepts that have around the origin. 0, 0. Both X and Y. Asymptotes, none, because it touches everywhere. In other characteristics, that have increasing and decrease. Let me show you that. Check them humps out. Increase and decrease. And basically here, For the cube root, like we just said, is the same as the cube function, but the miscellaneous parts are different. It has only increase. All right, let's get to it. Exponential and logarithmic functions. Let's talk about it. They are opposites of each other, which later on in when we get to this point, which is pretty much all of the last quarter, you're gonna realize that. But just by their looks alone, they are opposites of each other. So let's get to it. There's one keyword that I do want to address. It starts with the A, asymptote. So asymptote is when a graph gets closest to a point but never touches the point. And from what we did with our decimals, I'm sorry, I gotta draw that line a little bit better. It never touches 0. So let me ask you a question. Since we know it doesn't touch 0, let me ask you, by looking at the graph, the asymptote is going to affect which one, which characteristic, the domain or range. Why? It's going to affect the range because dealing with the y-axis. Because the range is going to be y got to be greater than 0. And because it didn't never touch 0, it comes dangerously close. 0 to infinity. The domain, the asymptote does not affect the domain, so the domains are real numbers. So alright, what about intercepts? By looking at the graph, it intercepts what? So what can we say about the asymptote? We could say the asymptote messes with the range and the y-intercept. Now, guess what we're going to do with logarithmic? Take all this stuff what we did with the exponential and put it in opposite places. So the domain of this logarithm is y got to be greater than 0. 0 to infinity. X, not y, I'm tripping. The range, y, is going to be all real numbers because again, you're doing the opposite of stuff. Intercepts x equals 1. The asymptote, of course, 0 at x. And this guy right here, the only thing that they have in common is that the asymptotes, messes with range and messes, well, let me correct this. Asymptote messes with domain and x-intercept. And I do apologize for the scrabble. It does look kind of sloppy, but if you was following along with this, or if you didn't follow along, replay the part and you will get it. All right. Woo! We made it to our last two functions. These are easy though, except for the rational functions. So let's talk about the absolute value function. Well, guess what? The absolute value function domain is for all the real numbers. And just like the quadratic, it has pretty much the same characteristics of the quadratic. 0 to infinity. The intercepts. You say the origin. Asymptotes. No, because it touches everything they wanted to touch. It doesn't. Let me make this clear. It does not approaches anything. It touches. Like it touches 0. It does not approach it. It touches it. Anything else V-shape wise? Miscellaneous all V-shape. Now, let's talk about the hardest one of them all. Rational functions. So let me help you out with this. What two functions does this resemble to you? It resembles both exponential and logarithmic. I mean, look at the shape. So, what else can we say in relation to the asymptote? Well, the rational function will have two asymptotes because the logarithmic have one and the exponential. And remember, you got two curves, so you got two asymptotes. When x is 0 and y is at 0. You think it's going to have any intercepts though? Why would it not have any intercepts? Well, think of the asymptotes. Because they don't cross the axis, that's why. They don't cross the x or the y axis because of the asymptote. It gets close to 0 but never touches 0. Close but never touches. So the intercepts are none. And again, the asymptotes mean they get close to but it never touches 0, so it don't cross the axis. So the domain range, this is how you're going to have to write it. Like this. So for the domain, negative infinity to 0, with the union, the u, I'll explain it to you a bit later, 0 to infinity. It'd be best for me to actually explain it now. It's only because, again, you got two graphs here, and that's for you use the union for this because you got two of them. Two graphs as one. And you can also think of this as a piecewise function too, but remember piecewise have all those conditions and inequalities here that you sign. Think of that as your inequality. And your range, you're going to copy and paste it like that. Negative infinity to 0 with the union 0 to positive infinity. And that's how you do that. Any other characteristics? No. Now you are officially done with that part. Now let's get to transformations. Transformations are easy. I know what's up. Those who was with me, remember this guy? Here they use D. I like to use K. But long story short, anytime you see a number outside of the function is to the far right, it just tells you the graphs move vertically, just up and down. So positive and negative, D or K, as I prefer it. Then in terms of it moving left to right, is what's inside the parentheses. Now, be careful of the trap, because we have to time file for it. When it's positive, it's going to move left, not right, because remember when you're graphing it, you're pretty much showing the answer to this. When you're writing it, you haven't solved it, but the graph is pretty much the answer to the graph. Answer to the function. So remember, positive inside the parentheses go left, negative go right. Be very careful of that, because it's so easy to mess everything up. Now, when you see a negative number in front of the in front of the function, it reflects over the x-axis. But when you see the negative side inside, and in front of the x, rather, is the y-axis. Okay? Vertical stretch and compress. When you got a whole number, yes, it vertically stretch. When it compress, you could say when you're dealing with a fraction. Again, this is only when you're dealing with a fraction. So when you got a fraction, like 1/2, that goes there. Horizontal compression and stretch is the same thing as the number in front, but the thing is, rarely will we worry too much about that. I would still talk about it just so you could, describe it if I was to give you a function. All right, so describe the transformation. The black is the original, but blue is the transformation. What happened to it? Another graph may be a little bit difficult to see, but it moves up by 1. So will the characteristic remain the same? Of course. Domain is still going to be 0. Well, let me take that back. The characteristics will mostly stay the same except for which one? Is it going to be the domain, the range, the intercepts, anything like that? Well, the range and the intercept will change. The range of this is going to be at 1. And of course, you really still don't have no intercept because it touches the axis but never crosses it. So that's essentially how you do this. Describe this transformation. It moved to the left by 3. Now the question is, how would you write this equation? So this is a cube root function, right? And the purple was the original. And the green is the transformation, so you write it as x plus 3 cubed. And let me explain a little bit first so you could not get confused with this. So if I was to solve this like an equation, x would be equals -3. Again, I took the inside of the parentheses, not the whole thing. And that's why you see that this graph moves to the left in the negative section instead of remaining positive. Because when you solve the equation again, it's going to result in a negative answer. And this is how you write the equation. Don't forget to describe it. Left 3. So you created the equation and you described it. Describe the transformations of the functions, of the function. What kind of equation is this? Or function? It's a quadratic. So what do we know about a quadratic function? It's a particular characteristic that stands out. Asymptote. Good job. So what do we know about this asymptote of the transformation? The purple is the original, the red is the transformation. So what is that asymptote? And don't forget, asymptote is get close to but never touches. It looks like it touches, but it never don't. So that being said, and we saw how the graph went down vertically, you could write this as b to the x minus 5 because that's what it moved down to. It gets close to 5 but never touches 5, but you include it in this sense. What about this transformation? We should know this one. We talked about it last semester, right before we took finals. So, the red is the original. And the blue is the transformation. So let's look at it. Ideally, when I get lost, I always like to draw points. Dot my paper. So I got 2 points here. I got 1, 1, and 2, 4. And this helps me out, because I know it's going to either stretch or compress. And it looks like to me, I look like I stretched it a bit, but let's find out how much by. All right, it looks like to me, as I move on to the transformation function, I stretched it by 1/2. So it's going to be 1/2 x squared. That's how you figure that out. Because you look at the points, it's just going all by 1/2 in terms of the. So let me explain this. I got 1 to 1, and then 1 to 1/2, and then 2 to 4, and then 2 to 1. And this is dealing with my transformation, so T with a mark. So let's look at 1/2 to 1. Well, that's going by 1/2. So I'm stretching all these points vertically by 1/2. That's the reason why you see the 1/2 outside the function. What about this one? So the purple is the transformation, the original. The black is the transformation. I know that's hard to see, but you could just pretty much just say just flipped. And it did. It just flipped. And of course it flipped on the y-axis. So there you go. So for this one, I'm gonna let you kind of not worry about this one, because it's very similar to what we did before. Ooh, let's dig into this little fun here. Here we are. So the black is the original. And the green and purple are the translations. So one of these functions, I'm going to leave this for you to find out. One of these functions are stretch vertically and one stretch horizontal. By you looking at this carefully, I need for you to figure this one out. I'm going to let that for you to figure out. Now, let's go ahead and describe these transformations of these functions. So, here, let's do it. Up 3, right 9, horizontal stretch 2, shrink by 1/3, and reflect vertically. So reflect shrinks vertically for these guys here. Horizontal stretch moves right by 9 and up by 3. A trick to remember in this is these deals with y-axis. Make this look easier for you guys. So this deals with the y, this deals with the y, and the inside is always the x. So the back and the front deals with y, and the inside deals with x. You try the second one, and you tell me what's up on that one. Miss Howard, why are you teaching us this? What's the point? Well, in Algebra 2, we're going to be dealing with the application, real-world problems of this. But Mr. Howard, that stuff is not real. That's just stuff that teachers tell us to make us feel a certain way. Well, on the contrary, those problems can't bore you to death. They got no relation to dealing with you, so you get bored of it. So I get it. And now, since we are high schoolers, getting close to working in the real world and such things like that, these functions are used for quadratic functions, are dealing with maximum and minimum. Think about it. You should know this from physics. You throw something in the air, it must come down, right? What comes up must come down. So you're dealing with the most or the minimum. If you play sports, you know about this already. Basketball, this, all that. Money deals with the same thing. Money deals with the most money you can make. Think about going to a fast food job. Managers, the corporate managers, always look at where is the time where they get most busy and the least busy in relation to handling the manager at the store and all the employees there. It also deals with space. Remember the area of a rectangle? Well, that's the area of a circle, but it deals with that too. So quadratic functions are always like x squared. Square roots deals with its length, but in terms of architectural architect stuff. So like if you doing engineer in relation to buildings and you want to get into constructions, you're gonna be using a lot of knowledge of square roots, especially when you will get higher up. But Mr. Howard, I ain't trying to do all that. But look, this is for in case you want to go higher in terms of finding jobs and stuff like that. I don't know about you guys, but let me tell you, when I was your age, I had no interest of working fast food after high school or just being cool with those kind of situations. I was one of the best, and you should feel the same way too. Anyway, getting back to square roots, anything that deals with movement, geometry, which is Greek for movement, you use that a lot. Exponential functions. When you hear people say that the population grows exponentially, they're talking about a fast growth, like it grows real fast. Logarithmic functions deals with the measurement of something in a period of time. So basically, science, so populations, those things, not natural disasters, all this, all that. And so exponential and logarithmic, again, because they are opposites of each other, they essentially are used for those things. So scientists, rapid growth or decline, how have you. Cubic function, all science that's deal with the third dimension and stuff like that. So that's why you're being taught these things. All right, a thought-provoking exit ticket. Describe and explain which functions and its characteristics are affected when transformed. So, and also your homework is all going to be in Google Classroom. See to it that you are there, taking care of business, getting everything done. Again, you want the homework to be done because next class we're going to, of course, discuss the homework, and the discussion is still part of your participation grade. So you really want to have it. And see to it that you do it complete and you're not trying to copy, because let me tell you, not a big fan of people who, cheat and stuff, because you fronting, you putting on front like you know, and then when it comes to a test, you cap through the test. You didn't know it. Again, I'm looking through these homework. I'm looking to see that you do it. Is it your work or someone else's work? And I got a good eye to spot a cheater. Trust me. All right, y'all.